ACT1. Fire and Iron, 0102 o'clock. Intro. The solitary pale blue dot visual, deep space. Silence. A single point of light grows until we see the present-day Earth spinning softly against the cosmos. Audio. Soft, ambient synth swells building into orchestral brass. Narrator. 4.5 billion years ago, there was no blue sky. No deep oceans. No green continents. There was only a chaotic cloud of dust and gas swirling around a young, aggressive star. Today, Earth is the only place in the known universe confirmed to host life. But to understand how we got here, we have to travel back to the raw, violent origins of our world, a journey spanning 4.5 billion years of fire, ice, mass extinction, and unyielding evolution. This is the complete story of Earth. 2 o'clock 5:30. The Hadean Eon. Birth in flame visual. Fast-paced CGI simulation of planetesimals colliding. A blazing red proto-Earth takes shape under heavy bombardment. Narrator. We begin in the Hadean Eon, a period named after Hades, the Greek god of the underworld. Gravity draws space rocks together, slamming them into each other at thousands of miles per hour. The energy of these impacts keeps the newborn Earth in a constant molten state, a shoreless ocean of liquid magma exceeding 2000 degrees Fahrenheit. Then comes the event that changes everything. A Mars-sized protoplanet, which scientists call Theia, strikes Earth at a glancing angle. The impact sends trillions of tons of vaporized rock blasting into orbit. Over just a few months, gravity pulls this debris together to form our moon, much closer and larger in the night sky than it appears today. 5:30 10 o'clock, cooling down and the first ocean's visual, volcanic vents releasing steam. Rain falls on cooling black basalt rocks for millions of years. Narrator. As the bombardment slows, Earth begins to cool. Heavy elements like iron and nickel sink to the center, creating a dense core that generates a protective magnetic shield. Carbon dioxide, water vapor, and nitrogen spew from thousands of active volcanoes, creating a primitive atmosphere. As temperatures drop below the boiling point of water, clouds condense. It rains, not for days or weeks, but for millions of years. Comets delivering water ice from the outer solar system join torrential rains to form Earth's very first global oceans. ACT2. The spark of life and the Great Oxidation, 10 o'clock to 2000, 10 o'clock 1400. The Archean Eon. Primordial soup visual. Underwater hydrothermal vents emitting towering black plumes. Macro zoom into microscopic single-celled organisms glowing softly. Narrator. Beneath the violent ocean surface, near deep-sea hydrothermal vents, chemistry turns into biology. Mineral-rich thermal waters mix with organic molecules, giving rise to the first single-celled organisms roughly 3.8 billion years ago. For over a billion years, life remains simple, single-celled, and microscopic. But these tiny microbes are working behind the scenes to transform the entire planet. 1400–1730, cyanobacteria and the Great Oxidation Event visual. Shallow turquoise waters filled with fossilized bacterial mounds, stromatolites. Bright green bubbles rising to the ocean surface. Narrator. Around 2.4 billion years ago, a revolutionary organism evolves, cyanobacteria. Using sunlight, water, and carbon dioxide, these primitive microbes perform photosynthesis, releasing a toxic waste product into the environment, oxygen. At first, the oceans absorb the gas as iron rusts and settles to the seafloor. But once the oceans are saturated, oxygen bleeds into the atmosphere. It is the Great Oxidation Event. While it triggers a mass extinction for anaerobic organisms, it sets the stage for complex life and creates the ozone layer, protecting future land creatures from deadly solar radiation. 1730–2000, Snowball Earth, Proterozoic Eon, visual. High-altitude camera shot zooming over a completely frozen planet Earth. A solid white marble in space. Narrator. The sudden rise in oxygen reacts with atmospheric methane, plunging Earth into its first global deep freeze around 2.1 billion years ago. Ice sheets miles thick crawl from the poles to the equator, trapping Earth in a global ice age known as Snowball Earth. Life retreats to hydrothermal vents and beneath ice shelves, waiting out millions of frozen years until volcanic eruptions breach the ice, venting enough greenhouse gases to melt the planet back to life. ACT3. The Age of Monsters, 2032. 00–2000–2400. The Cambrian explosion and life reaches land visual. Vibrant underwater reefs populated by anomalocaris, trilobites, and early jawless fish. Transition to early green moss spreading onto damp coastline rock. Narrator. By 541 million years ago, the oceans explode with complex creature design, an evolutionary leap known as the Cambrian explosion. Shells, eyes, spines, and predators emerge. Over the next 100 million years, plants colonize dry land, followed by arthropods like giant dragonflies and millipedes. Tetrapods, four-legged amphibians, eventually crawl onto the mud, breathing air for the first time. 2428, 00. The Great Dying, Permian Triassic Extinction, visual. A dark, ash-filled sky over massive lava flows, Siberian traps. Dead landscapes strewn with bones. Narrator. Life spreads across the supercontinent Pangaea, but 252 million years ago, the planet reaches its absolute breaking point. Massive volcanic fissures in present-day Siberia erupt continuously for hundreds of thousands of years. The Permian extinction, the Great Dying, wipes out over 90% of marine species and 70% of land animals. Oceans turn acidic, the air turns poisonous. Earth comes closer to becoming a dead world than at any other moment in history. 28:0032:00. The reign of the dinosaurs and the asteroid visual. Lush prehistoric jungles populated by T-Rex and Triceratops. A massive glowing rock streaks across the blue sky, hitting the ocean with a blinding flash. Narrator. From the ash of the Permian extinction emerges the most famous lineage of all, the dinosaurs. For over 160 million years, they dominate every continent, adapting to rainforests, deserts, and coastlines. Then, 66 million years ago, a 6-mile-wide asteroid strikes the Yucatan Peninsula at 45,000 miles per hour. The shockwave triggers megatsunamis, wildfires, and a winter of ash that blocks the sun for years. The age of dinosaurs ends in a single catastrophic afternoon, leaving small, underground-dwelling mammals to inherit the Earth. ACT4. The Rise of Humanity. 32:00:00:32:00:36:00. The Cenozoic era and the Ice Ages visual. Continental drift shifting landmasses into modern positions. Woolly mammoths walking across snowy steppes. Narrator. With the big reptiles gone, mammals rapidly diversify. Continents drift into their modern locations, shaping ocean currents and cooling global climates. Over the last 2.6 million years, Earth enters the Pleistocene epoch, characterized by repeating cycles of glacial expansion and retreat. Mammoths, saber-toothed cats, and giant sloths roam vast grasslands under cold, dry skies. 36:00:40:00. The Anthropocene. A new force of nature visual. Early hominids gathering around a fire, transitioning rapidly into time-lapse satellite views of modern cities lighting up the night continent by continent. Narrator. In East Africa, the lineage of primates adapts to changing climates by walking upright, developing complex brains, and mastering fire. In just a few 100,000 years, an eye blink on the geological scale, Homo sapiens spread across the planet. We farm continents, alter rivers, build cities visible from orbit, and begin reshaping the global atmosphere once again. ACT 5. The Future of Earth. 40. 0045. 00. 40. 0043. 00. The Distant Future Visual. Time-lapse map of continents slowly merging over millions of years, followed by an expanding, hotter red sun roasting the surface into desert. Narrator. Earth's story is far from over. In 250 million years, plate tectonics will reassemble the continents into a new supercontinent, Pangaea Ultima. In 1 billion years, as the sun slowly expands and grows hotter, Earth's surface water will evaporate, ending the era of surface life. Eventually, in 5 billion years, our dying star will expand into a red giant, swallowing the inner planets, including the rock we call home. 43. 0045. 00. Outro. The miracle of the present visual. Slow zoom back from high Earth orbit, showing the fragile blue atmosphere against the void of space. Audio. Inspiring, quiet orchestral piano solo. Narrator. Earth is a dynamic machine of fire, rock, water, and life. A planet that has burned, frozen, died, and reborn itself time and time again. We live in a rare, golden window of planetary history. Out of 4.5 billion years, we exist in the brief sliver of time where Earth is green, conscious, and capable of looking back at its own story. Thanks for watching. If you enjoyed this journey through time, don't forget to like, subscribe, and hit the notification bell to explore more mysteries of our universe.